So moving on to question number 5, it is just similar to the previous question that we had, which is question number 4. If you check, we had 1 over 2 and 1 over 4. So now you know, guys, how to rewrite 1 over 2 in terms of what? The least exponent 1 over 4. So you simply raise to the exponent of 2. We had this one from our previous question. So here we are going to rewrite x to the exponent of 1 over 4 raised to the exponent of 2. Then the rest rewrite as it is. So you're going to have minus 5 x to the exponent of 1 over 4 minus 2, which is equal to 0. So that is it. Let our k represent what? X to the exponent of 1 over 4. And thus we can at least have a simpler equation that we understand. Not to say we cannot solve this. We can solve as it is, but we just need something that is what? Simple to work with. So meaning to say, in place of x to the exponent of 1 over 4, we're going to have it as what? As k. So that's k to the exponent of what? Of 2. Minus 5k minus 2, that's equal to 0. So solve this for k using any method that you understand. Going back to our factorization, let us factorize this separately. 3k squared minus 5k minus 2. So to factorize, remember, any method that you understand. Using the cheat method, just multiply this one by 3. So you multiply, meaning to say you get rid of this one. So it's going to be k squared minus 5k, 3 times 2, that's negative 6. All right, easier to factorize. You are used to this. What are the factors of the constant negative 6? And these factors must add up to negative 5. So negative 6 and 1, 6 and negative 1. There are so many 3 and negative 2, negative 3 and 2. But which of these, when you add, you get a negative 5? It only happens here. Minus 6 plus 1 is what? Negative 5. So those are the ones that we need. Negative 6 plus 1. Do not forget to bring back the coefficient of what? K squared. In place of k, put back the 3. Put back the 3. Then factorize where possible in these brackets. Factorize. Which one can we factorize? The first one, 3 is common between 3 and 6. We can factor out 3 as our highest common factor. So that's 3k squared, and 3 is going to give us k, minus 6, and 3 is going to give us minus 2. The second bracket remains as it is. We do not have anything common. So the 3 that we factored out is not part of our question. So meaning to say, these two brackets will be the factors of what we have on that quadratic. So that's x minus k minus 2 into 3k plus what? Plus 1. Solving for k from the two brackets, and remembering that we are dealing with x to the exponent of 1 over 4. So we dealt with this condition in our previous class, and I said whenever this happens, x to the exponent of 1 over 4 must be positive. So it must be greater than 0. So you must put that into consideration. The first bracket, negative, is going to change to a positive. So k is equal to 2. Then negative here, positive changes to a negative. So it's going to be negative 1 over 3. All right, 3k is equal to negative 1. Then divide by what? By 3. So from this, substitute or take back that k, which is represented by x to the exponent of 1 over 4 to solve for x. So x to the exponent of 1 over 4 must be equal to 2, or x to the exponent of 1 over 4 must be equal to a negative third, where This cannot happen that the fourth root of a certain number is a negative. Which fourth root of a negative number that can give us a negative 3? From our calculator, this cannot exist. So meaning to say, here we do not have a solution. We are just focusing on this part. Remove the exponent. What is the reciprocal of 1 over 4? That's a 4. So to the exponent of 4 to the exponent of 4. Just like that. So from here, you're going to have the value of what? Of x. So 2 to the exponent of 4 was going to give us what? A 16. So that's the only solution that we are going to have. The other one, there is no solution because of that fourth root. We cannot determine, we cannot have the fourth root from a number, then get a negative from there, from our calculator. We are talking about what our calculator is giving us direct. So just revise as many questions as you can.